Let's jump in.
Yeah.
Okay, awesome. I think we got a good crew here. All right, Al, today we are gonna do, let me share the paper. We're gonna go through LIMA. LIMA stands for less is more for alignment. Paper out of Meta, CMU, USC, Tel Aviv. So we'll go through this paper. I think there's Q&A in the Zoom, but then there's also Q&A in the Rise community. So drop questions. Let's make this conversational and dive into it. Okay, well, Jason, maybe we could start off with like, what was your big, you can both, I think we were talking about it right before the call, but like, what was your big takeaway from the paper?
Yeah. I think the biggest takeaway is how much you can get with how little fine tuning that I feel like there's a feeling in the community of those who are actually fine tuning these models post like you get the base model like a llama, and then you fine tune to say an alpaca. And if you talk to people who've actually done it, I saw a talk by Rohan, I think Tarori, who did the alpaca. The comment was kind of like all the knowledge is kind of built into these base models, that all of the idea of the structures of the world and structures of language and all the ideas contained in it that make them work are kind of contained in these big training runs, which are a little bit of like large training run plus black arts magic in putting the data together. And then these final fine tunes kind of let you let the model express that knowledge it has in a way that maybe works for people or works well. Like it says it in a way or explains it in a way that humans like to interact with. And I think what's surprising about this is how little you need of that last stage. I think that's the point here, is that they're trying to make is that very selectively fine tuning in the end is quite powerful. I think that was the amazing takeaway I had.
Yep. I think there's one line actually in the paper that I thought was like a great summary. The entire paper. Let me go to it. Actually, it's exactly what you're saying, which is we define the superficial alignment hypothesis. A model's knowledge and capabilities are learned almost entirely during pre-training. So this is kind of the base model, what's actually there during pre-training. This is really where the majority of its capabilities are cemented, while alignment teaches it which sub-distribution of formats should be used when interacting with users. And so this was kind of like, well, alignment at the end, is it what format should the response look like for what scenarios? So when should you respond with, I don't know if it's like what type of a little bit more casual versus I think there's a lot of depth into what is sub-distribution of formats, but it really did feel like this is kind of the layer of user interaction that's really what alignment is focused on. And to me, this actually got me thinking, I'd love to see a alignment versus prompt engineering down the road of, how far can you get with prompt engineering versus how far does alignment, how far can alignment take you? And maybe the gap's really big today. But yeah, that's kind of what, this was kind of like a really critical like thesis, I felt like, of the entire paper.
Yeah, I agree. And I think there's also a subtle point here where you have the right set of fine tuning at the end here or alignment, and you probably need to prompt engineer less, because there's a very natural, I ask this, I get this format, I ask this, I get this format, and it just, you're kind of fine tuning at the end so that I think that's one of the things with the difference between maybe ChatGPT and the original GPT-3, which is like you had to like work a lot to get the right response out, and then it just started responding much better. So I do think like you get the right fine tunes right, and you probably need slightly less prompt engineering, but it's probably very dependent on what you're trying to get out of it too.
Yeah.
So assuming the things in your response and response formats are in the fine tuning set, you're probably good. If they're way out of totally different, I want this crazy JSON format of something, or like there's probably things that aren't in there that you're probably gonna have to work quite a bit for.
Yep. All right, well, let's dive in. So looks like I was actually surprised, really small subset, only 1,000 prompted responses in total that they experimented with for this alignment, but they collected this data from 3 different community Q&A websites: Stack Exchange, WikiHow, Reddit data set. Maybe try to see if you can pull them up, Jason, while we're going through. That would be interesting. And in case you've never heard of them, they gave you a good little description of what each of them was. My favorite was the Reddit one, which was, it's a little bit more witty, sarcastic versus informative. But basically they collected data from these data sets. And then I think what was interesting to me was that they really put a lot of effort in making these responses high quality as possible. So even though there's a really small subset, only 1,000 samples, they really focused on the quality of that 1,000 examples more than quantity here, which is maybe a good note to people on the call who are thinking about, well, how do I improve the outputs of LLMs? It's really about the quality at the end versus quantity. So what did they do? So they grabbed, so they spent some time actually diversifying the data beyond just questions in online community sets. They also had, group A, group B kind of generate some prompt response pairs as well. And this kind of just gave them, I think they hinted at it here, which is just, this was really laborious. Creating a really high quality data set was really tough. This kind of made it feel like labeling might not go away anytime soon. Like labeling there's still some use cases for labeling, even in the LLM world, which is a good takeaway of this. Okay, let's keep going. So anything else you wanted to add there, Jason, on the data set side?
No, I think that's it. I mean, I think there's I think the other takeaway is and I'm hearing this a lot. I'm hearing this from the people building the models and the people fine tuning, is that data quality starting to matter a lot. Like thinking about both the data quality, which you build your model from, in the open source community, there's something called the pile, which is a really big internet scraped data set that is designed for the base model builds. So those would be, think of those as like the Luther folks use those to build those GPTJs and Pytheas. And so there's a data set, but the curation of it, and then the curation of your the curation of your fine-tuned data set actually matters a lot. And it's funny, like there's a dark art of search where like, oh, you weight up the index based upon this type of action, you weight it down, and it's, you build this knowledge over the years. It certainly feels like in the base model building, there's a lot of that dark magic. Like people say you weight up Wikipedia, for example, versus, sources that, or have really good knowledge. And so there feels to be some of that little bit of like data quality stuff also matters on the fine-tune side. Like when you go to fine tune, probably getting that right data set in place makes a lot of sense.
Yep. I think that's interesting. All right, well, let's keep going. So they actually trained LIMA, started from, in this case, llama. I think there's a little bit of a note of just some data quality stuff here too. So using an end of turn token. I don't know, this came up a lot in some of the like paper explained. So that was interesting. So once they actually trained it, they went through a couple of different evaluations of LIMA against several other state-of-the-art language models. And the results are actually worth digging into, actually. So they compared LIMA against 5 different baselines: Alpaca, DaVinci, Bard, Claude, GPT-4. And basically what they did was they gave it this is one where they basically tested, well, against what is a human's preference of a response on LIMA compared to these other 5 state-of-the-art language models. And then they also ran it against GPT-4. And then they kind of compared and said, okay, well, the results are actually pretty similar. So that was really interesting. They had a human evaluation, and then they also had an LLM evaluation. And in both cases, I think LIMA was most times looks like, definitely better than Alpaca, but it still looks like GPT-4 is better than LIMA. So it's kind of, it's really interesting that in both of these evaluations, that was kind of the same ordering of preference.
Yeah, and I think the alpaca one is like one of their main points too, that alpaca is like the llama trained on 52,000 a 50K data set that was actually, I think, generated using GPT or text Da Vinci. And so like they generate 52,000 kind of question answer examples and different types of prompt response stuff. But the fact that like just 1,000 fine-tuned samples beats the alpaca is kind of one of the points they're trying to make too.
Yeah. Yep. So yeah, it's a good point. Let's dive into like what were those 5 baselines. So there's alpaca, which was fine-tuned on the 52,000 samples. There's Da Vinci, which was tuned with reinforcement learning from human feedback. So it's kind of a comparison against RLHF. Then they have Bard, Claude, which is trained with reinforcement learning from AI feedback. And then GPT-4, which is also trained with RLHF. And so, yeah, you're right. Like the alpaca and the Da Vinci were kind of like the 2 that I think they were trying to make a point with, that it was better than, the 52,000 sample points and RLHF here. Let me see if there's next section we could go through. This one might be an interesting part to go through. So it kind of talks about, well, what's the how did it do on out of distribution samples? So when you ask questions that were outside of the training distribution, how did it do? Looks like in general, it had similar absolute performance statistics outside of its training distribution. It's able to generalize well. The one note that I thought was interesting was it's more likely to produce unsafe responses. So that was one where I think it small little note of safety was maybe one area where it was slightly less than state of the art. Yeah, and then I think the rest is really just like a discussion on why is less more. So they had all these results of, okay, well, here's kind of how it compares human and GPT-4 evaluations. And then there's kind of a conversation of why, like why only with 1,000 samples is this doing as good as it's actually doing? And this was interesting. I think that the 2 points that they seem to like, I feel like the paper is really highlighting is input diversity and output quality have the biggest kind of positive effects. So even though it was only 1,000 samples, the diversity of the 1,000 samples mattered a lot. And then the quality of the responses in those 1,000 samples really had the biggest impact compared to like the 52,000 from alpaca. And maybe there's a nudge of like the ones that were generated from GPT, whatever 3 weren't that high quality versus the output quality of the ones fed here were, I don't know if they were human generated, but significantly kind of better than the 52,000.
Yep. Agree. And I think the going forward, the question is going to be like, how do you create these data sets and how do you refine them and where do you like, and how much is enough? I mean, there's just so many things that I looked at and was like, hard to know. and what I'll do, I think as we get through this at the end, I wanted to talk a little bit about like, man, there's an explosion of this fine tuning going on, and there's whole leaderboards on Hugging Face right now with like, everyone fine tuning something to try to get above someone else. So this is kind of like, trying to get hints at like what's the magic, but I also think like everyone's throwing everything at it right now and trying different approaches.
Yeah, like I did feel like one of the things I felt like after reading this was like, is there a score to be able to measure something like an input diversity or an output quality?
Yeah.
Like they kind of had, okay, well, in the data set to test the effects of prompt diversity, they had a couple different data sets, Stack Exchange data, which has heterogeneous prompts with excellent responses. I was actually really curious about that because I thought a lot of Stack Exchange was just about, tech and coding. So I didn't know how heterogeneous it was going to get. And then it said WikiHow data, which has homogeneous prompts with excellent responses. That one kind of threw me, but I'll run with it. But like, it was interesting how they defined like what is heterogeneous prompts here? How are they measuring that? Are they measuring, like you could kind of read as a human, you could say, okay, yeah, these are great responses. Is there any way of knowing that so that when you look at your data set, you have a way of scoring, is this really good enough data?
Mhm.
And maybe that would help with being able to know, well, how much data do I really need? Do you need some threshold or some cross where you really start to notice a difference? So that this is one where I'd love to see a way to measure this.
Yeah, and maybe we could talk a little bit about let's keep going. We'll show you maybe the leaderboard at the end.
Yeah, yeah. Okay, so this is probably one of the best parts of the paper, the actual examples. So they tested this on, and we'll go through it. So they tested this on single, I guess like a single conversation or single step conversation where they asked a question and then they got an answer. And then they also ran this on, okay, multi-turn dialogue where they asked a question and then they did multiple, they asked a question, then they asked a follow-up question, they asked a follow-up question. And so let's maybe go through each one of those. So in the single turn dialogue, I guess, this is some examples of in distribution. My daughter is super smart, finds the kids in her school boring. How can I help her make friends? Pretty great response of this. And then this was one where it's kind of out of distribution. So write a stand-up skit in the style of George Carlin that ridicules PG&E. And so this is one where there's probably not a lot of training examples on something like this. Write a script that ridicules, I don't know, some electric gas company. And so just an example of kind of two different types of samples that we're trained on.
And it's worth noting too, I thought was really interesting is two things of note is they did do human preference as a like one question is like you look at these and you're like, how in the world are we going to judge ground truth on this or understand performance? And they did do human preference, but they also for the evaluation study use GPT-3 to do evals. So you're seeing that a lot, which is let's use an LLM to do at scale evaluation. So I think the major results were human preference, but also there's a note of GPT-3 evals.
Yep. I think the interesting thing here, so this is kind of the visual here of like comparing the human versus the GPT-4. And I think the interesting note of this is like they actually match pretty closely, which is a great note for GPT-4 evals. Right? Like it's ordering still the same of what GPT-4 got versus what the human preference ones got, which is really awesome, I think. And I think in both of them, of course, GPT-4 is still better, but it's really close.
Yeah.
How good these are. It like this was one where I left thinking, wow, something like annotation, labeling. I mean, this is a dang good data point of where GPT-4 could really be doing those annotations or I don't know, scoring.
Yep. Agree.
I have a question from Nisha. That's a great question. Interested in what factors you think influences input diversity, concepts, language, sentiment, etc. Great, great question. I'll share the part that they hit on. I had this question, to be honest with you, Manisha, too. This is kind of what they hinted at in the paper. So they have call it the three different their data sources, which was WikiHow, Reddit, and then Stack Exchange. And then what they called it kind of filtered Stack Exchange contains diverse prompts and high quality responses. Unfiltered Stack Exchange is diverse but does not have quality filters. WikiHow has high quality responses, but all of its prompts are how-to questions. So it looks like they're all like, that's kind of what they were getting at earlier when I was saying they said Stack Exchange was heterogeneous, but WikiHow is homogeneous. They're kind of getting at like, a lot of the questions, at least from WikiHow, I don't know if it's like formatting of the data is like maybe one of their biggest things of input diversity.
Mhm.
I don't know about concept like that was kind of what I thought too when I was reading. I was like, Stack Exchange must have a lot about technical subjects. But I didn't see that in the paper itself. It really seemed more of like formatting,
Yeah.
kind of the big no.
I think there's an interesting point here too, which is like if you're thinking about like the bias angle of the model, like the raw big thing you built on probably contains all the ideas and concepts related to every negative subject you could think of. And then this these final stages where they fine tune, and maybe they do downweight. Like we don't know how Meta doesn't tell us how they built the data for Llama, or at least doesn't.
Yeah.
I don't know how much they get. I don't think they get. They don't give. They give hints at it in papers, but it's not like you know exactly. So you don't know if did they downweight certain things that were negative. And then you also don't know what like. I just think there's this final stage here, which maybe it doesn't express the things that it knows in the way so you don't want, but it still might. They still might be in. It's concepts around those negative subjects still might be in there. So I think there's a and that's why they call it alignment. In the end, you're trying to like make sure the way it's expressing these things aligns with what you want it to do, even though those subjects probably do exist internally in some way.
Yeah. And if you're curious, this is kind of the set of their 2000, the examples, or 1,000 examples, sorry. So this had the set of Stack Exchange STEM, and then they had Stack Exchange Other. So I guess they did have a decent, half was STEM, half was, you're right, they did say that somewhere above. 75 STEM exchanges and then 99 others. So this is like English, cooking, travel, and more. And then we sampled the 200 questions and answers from each set using a temperature. We take the questions with the highest score, blah, blah. We filter answers that are too short, so less than 1,200 characters. If anyone's ever writing answers on Stack Exchange and you want it to be used for people's training data, this is what you need to fall under. So answers that are too short was less than 1,200 characters. Too long was more than 4,096 characters. Written in the first person, so I, my, were all filtered out, or reference other answers. And then they remove all these other like links, images, etc. So this is kind of where they ultimately landed. It was like some from Stack Exchange, some from WikiHow. And then they did a test on also just, they kind of had a group A, group B of people just ask questions as you would ask your friends. And then what would a high quality response have been like? So things like advice that you normally probably wouldn't put on Stack Exchange or WikiHow, they asked more they asked humans that. So my guess is questions like this one, my daughter's really smart and she's finding the friends in school boring. Like this is probably one that was maybe from more of the friend advice type questions.
Cool. I thought I'd show some of the leaderboard stuff going on.
Yeah.
If there's, and this is kind of, this is new. I don't know if everyone's caught this, but there's this leaderboard now on Hugging Face, which everyone, so there you have llama, you have alpaca here. You have a bunch of different, you have tons of different models and tons of different fine-tuned versions of it. So Vicuna, it's a fine-tuned version using a website, which is like, there's a website out there that captures ChatGPT statements and like, everyone was trying to save their ChatGPT conversations. Well, why not train Meta's Llama on ChatGPT prompt and responses, fine tune it. So there's like fine tuned versions on ChatGPT. There's a ton of these. GPT-4 is so there's alpaca here trained on, there's a bunch of these, and most of them are like llama type llama type fine tunes. And what's meant by that quickly is there's kind of this base model from Meta Llama, and there's this instruction fine-tune set, and then basically you create alpaca by fine-tuning this big model. So there's all these variations. You'll hear all these names: alpaca, llama. It's why, like, at the Hugging Face event, there was a llama outside. It's like Attack of the Llamas. And so how you create this, your training. So that, the one we just looked at, LIMA, was only 1,000 samples. They, collecting and creating this 52,000 is hard for a Stanford group on a limited budget. So they actually used, Text DaVinci and others to actually create the 52,000 examples that they use to create alpaca. So LIMA, which we just went through, is 1,000 sample version. Training Llama, Meta actually was the person behind that. But you can see a million versions of different models and fine-tuned versions, and almost all these, I would say the vast majority of these are Llama based. Falcon's new. The top of the list just came out last week, their paper. Falcon's new. It's the best open source. Yeah, I don't think it's Llama based. So it's trained on its own pile, the pile data set. So it's not Llama based, but worth noting, there's this huge leaderboard that's out there now. And then there's each one of these, it's worth noting, is a different set of types of questions. So they're like the SATs for LLMs, I guess, SATs and ACTs for LLMs. Lots of different data sets with pretty complex different types of questions in it, and they're just kind of averaging to get you a benchmark. So worth noting, fun to follow. I think everyone's trying to, there's a lot of graduate students trying to get the next spot on the leaderboard.
I like there's all these different, there's truthful QA, hella swag. Like, those are some interesting names for evaluation.
Yeah, this one's, I think, interesting. Let me see.
Sheen, really finish your sentence. Okay.
Yeah. So it's like, sentence completion. So yeah, they're quite diverse in the different types of things they've added, and I think it's awesome Hugging Face set this up. It's like, it was kind of a mess before. So it's kind of interesting to see who pops up, and the fact that Falcon popped up in the last couple of weeks, okay, it's worth a paper read. But a lot going on here. I also worth noting, like, some of my last little note to anyone on this is like these ones that you build internally. I still haven't seen like GPT-4s doing something magical in that interface, or like there could be like a million black arts going on behind the scenes to make the whole thing work really well. That a lot of these kind of self-built stuff just don't quite perform up to what we experience in those interfaces. So, but so simple, if you're just a company trying to run on your own data, these work well for something simple. Cool. Any more questions?
Yeah, any questions, comments, any notes you want to share? Awesome. Well, if not, drop some suggestions for next week's paper. I think there's a good, I think I was thinking, let me pull it up actually. I think I was thinking of doing the spring paper. With GPT-4 outperforms RL algorithms. That one's a good one. There's also the one I think you had sent me, Jason, about agents and
Yeah,
GPT-4 um uh
the
outperform.
Minecraft, that's a pretty amazing one. That would be a fun one next week. So we'll figure it out. Maybe you put suggestions in. We'll look through and figure out some good ones.
Oh, cool. Oh, it looks like we have one last question in the chat. Ethan Shautran asked, do we think the future of RLHF is just 100 data points as opposed to building robust, large RLHF data sets for specific cases, the hospital?
Yeah, I think that's like a great, outstanding question. I I'll tell you, there's one thing. I guess there's a bigger debate we're having internally here and across our customer base, which is like, it's the fine tune versus in content, like context prompt information. So what do you decide to fine tune? And RLHF is a method of, of that. Or what do you decide to just, what should you just be putting in the prompt so that the model is responding in the way you want? And I think that's a debate a lot of companies are having too. Like, should I go even fine tune, or can I just get what I want out of like prompt engineering, the context? So I think what we're seeing is it makes sense to fine tune if all of your customers, if the attribute or thing you want to change across everyone interfacing with the model, should you want to change it for everyone. So they'll maybe RLHF or fine tune one thing, so maybe it's slightly better in some area, but then the context is what you use for a lot of the variability you might get on a daily basis. So I think there's a big question: how much do you fine tune versus how much do you prompt engineer? So that's like the biggest one. And then I think if you're assuming there's going to be a lot of fine tunes, I could imagine doing them for certain environments or certain responses, which I think was the point there. Like if you're in a certain environment and you want the model to act and respond in a certain way, like you can imagine the way mathematicians talk are like different than regular people, and maybe you you could fine tune in a way that like it's always responding in that way. But the question is, can you get that through the context? Could you just prompt engineer your way to that same experience? So I think that's the biggest debate we're having internally. Anything else you'd add?
Yeah, I mean, I think like there is also a lot of conversation going on right now about, especially with Meta's claim that pre-training is more important than fine tuning. I think that it may not hold true for all tasks, all domains, but something like a language model for specifically like medical diagnosis might benefit more from fine tuning than something like this example here where it was just conversations. So I think there's still a lot to be experimented with around what is the boundaries of fine tuning versus where's the boundaries of alignment, what's the boundaries of really just a whole new language model. And then of course, with all this prompt engineering and in context prompting. And I think those lines are very, very blurry right now. There's kind of a general arc of where you stop seeing, marginal returns on each one of these. So you first try the easy approach of in context training, in context prompting, and then you can go to the harder and harder approaches. But I'd love to see some of these LLMs being deployed in those use cases like hospitals for us to see where they landed on it themselves.
Yeah. So there's a question on fine tuning here in our LHF, and like, do we help with that? So we're an observability platform. So we only we typically are looking at like analyzing results. So that if you're thinking of actually training a model, there's there's a couple places I probably would point you for fine tuning. We actually do have a session. We're doing one with AnyScale, for example, on Thursday, where we're doing fine tune in LLM, and then we actually analyze the post results. So if you're in San Francisco, that's a Thursday event. But Mosaic or AnyScale could be like places to go to think about it if you're like a corporation or company trying to do something somewhat complex. Those two. AnyScale slightly more open source. Mosaic's probably larger, but has bigger foundational models. And then if you just want to do something smaller privately, I'll drop a note. There's Hugging Face has some good examples. I'll drop in the thing. They have a good like example. They put out some open source. So the people at Hugging Face put out some open source libraries for fine tuning, and I feel like there's a lot in that on the write-up and in different ways you can do it, but tons of examples out there for fine tuning if it's small model in a notebook. That's kind of where I'd maybe suggest first, get it working, small model, something you can run in a collab, and then extend out to like something larger size, like AnyScale, which will allow you to scale that out, or a Mosaic. So that would be my recommendation. And then once you're done, we have tools to help you analyze results. And then if you're in San Francisco, we have a LLM fine tuning event this Thursday.
Cool.
Cool.
Awesome. Well, thanks everyone for being part. See you guys at the next one.
Awesome.
See y'all. Bye.